In this problem, we're going to work on solving a circuit that does not have distinct routes. So as you can tell, if you trace around from the positive side of the battery to the negative side of the battery, on one route you could go through resistors A and C. On the other route you could go through resistors B and C. So how I want to tackle that is I want to talk about different paths. And then we will group resistors together as being in series or being in parallel. So I'm going to start by drawing a dot on either side of the battery and at any intersection I see. Then I'm going to define from one dot to the next as a path. So this first path doesn't have any resistors on it. Then we can tell that the current's going to split. Some will go down through A, some will go over through B. And those currents will split. One path goes through A, one path goes through B. Then the currents will come back together, and all the current will travel through C. So I want to group these resistors together, either into parallel or into series. So I always look for a series first. A series are two resistors that are both going to get the same current, so there's no intersection between those. In this problem, I don't see any resistors that are in series. So then I look for the resistors that are in parallel. So parallel means that there's one resistor on each path, so the current splits, there's one resistor on each path, then the current comes back together. So A and B are in parallel. Alright, so I'm going to redraw this circuit, so I still have my 12-volt battery. And I'm going to draw around. And then instead of drawing resistor A and B separately, I'm going to combine them together. I'm going to call that resistor AB. And resistor AB will have a resistance. I'm going to use the parallel equation. So 1 divided by the quantity 1 divided by 50 plus 1 divided by 30 will give the equivalent resistance of those two. And that gives me 18.75 ohms. Alright, so then I still have resistor C right here. And resistor C is 40 ohms. So now if I look, I just have this one route, so one path, and resistors A and B can be combined together. But now since there's no splits, resistor AB along with resistor C make a series. So let me redraw this. With just one resistor. And I'm going to call this resistor ABC. This resistor I can take, since they're in a series, I can take 18.75 and add 40, and that'll give me 58.75 ohms as the equivalent resistance of the entire circuit. So I'm going to write that in the source row on positive physics as 58.75 ohms. Alright, so next step I'm going to go ahead and fill out some given. I have the resistances of A, B, and C as 50, 30, and 40 respectively. And I know the voltage of my battery is 12 volts. Alright, next thing I can do is I know that once I get two things in any row, then I can figure out the rest of the row. So right now I know the resistance and the voltage of the source, so I can use the equation I equals V divided by R, so 12 divided by 58.75, and that gives me 0.204. And that 0.204 amps is going to be the current that is coming out of the battery, so 0.204 amps. So that current is going to flow around to our first intersection where it'll split. Alright, so next I need to figure out how much goes towards A, how much goes towards B. I know they won't split evenly because more current always tends to go towards less resistance. But what I can do actually is I can figure out the voltage for A and B. To figure out the voltage for A and B, I can use their equivalent resistance of 18.75. So next I'm going to use the equation V equals I times R, and I'm going to do 0.204 times the equivalent resistance, which was 18.75, and that'll give me 3.83 volts, which will be the resistance for A and B. Now that I know the voltage for A and B, I can go ahead and figure out the currents by doing V divided by R. So 3.83 divided by 50 gives me 0.0766 for the current flowing towards A. And the current flowing towards B, 3.83 divided by 30, gives me 0.128. A good way to check my answer right now is if I added these two currents together, I should get 0.204. Alright, next I know to figure out C, I have a couple ways to do this. I know that those two currents are going to come back together, and all of the current, so all 0.204 amps, will end up going through C. And that will give me a voltage of 40 times 0.204 of 8.16 volts. So how I can check my answer right here is I know on each route the the voltage used at the resistor should add up to 12. So if I added A and C together, or if I add B and C together, I should get a voltage of 12, which I do. Alright, lastly, to calculate the power, I can just use the equation P equals I times V. So 0.204 times 12 gives me a total power output from the source of 2.45 watts. 0.0766 times 3.83 gives me 0.293 watts. For the power dissipated at A, 3.83 times 0.128 gives me 0.490 for the power at B. And lastly, for the power at C, 0.204 times 8.16 gives me 1.66 for the power dissipated at C. Again, because of conservation of energy, if I add up 0.293 plus 0.490 plus 1.66, I get 2.44. There's a slight difference because I was rounding, but that should always equal the power provided by the battery because of conservation of energy.